All right, the last section here is kind of just miscellaneous good knowledge to have. So we talked about in the Windows module, the IIS being Microsoft's web server, and I kind of broke it down for you. For Linux will be Apache, Windows will be IIS. So pretty much the Apache web server, it's free and open source. That's why it's run on most Linux-based systems, because Linux is also a free and open source operating system. It's just the web server, supports a range of programming languages, and the takeaway is it can run on Windows. You can stand up Apache on a Windows operating system, but why wouldn't you just run IIS instead? So this is generally how it's broken out. Just wanted to make you aware again, since we're covering the Linux module, the main Linux web server that you can spin up is the Apache software. Speaking of software, we should cover packages and patches. So we have our terms here. A software package, what is this? It's a collection of files that make up an application or a library. They can be installed and managed as a single unit. We know what packages are, we know what software is. Some examples, if we have RPM, Red Hat Enterprise Linux, running the RHEL operating system, this is the package manager that we would leverage for RHEL. We would use the Red Hat Package Manager. An example of command, we can do rpm tac I, give it the package.rpm name. This would install the package, and then if we wanted to remove a package, we can do rpm tac E to remove a package. So why are we covering this, and why am I giving examples? Linux will oftentimes go onto the system and be like, oh, we got to patch it for the latest updates, or I need to install a tool, or I need to do something for installing software. You're going to be leveraging different commands based on the Linux operating system that you're on. And if you've never heard of, RPM command or the yum command or apt-get install command, you're just going to be a little bit behind the curve. So moving into a patch, software update that fixes a specific issue or vulnerability in an application or an operating system. When we're we're updating it to make it more secure, patching that vulnerability, increasing our cybersecurity hygiene and posture within the organization. So you can have yum, you can have apt. These are package managers used in various Linux distributions. So some example commands, you can run yum update or yum install, get your package to update or install packages using yum. Or you can do the apt-get update or apt-get install, name of the package, to go out and grab that update or that package using the advanced packaging tool. So, RPM, yum, apt, maybe like apt-get. Have a familiarity of what these commands are. They're software packages, patch management, based on the Linux operating system that you're using. Definitely shouldn't be the first time that you're hearing about them, moving on to your other courses that you take after this, so that is why we are covering them here. All right, everybody remain calm. We all love IP tables. I just make a joke because it's like someone's asked, oh, how are your IP table skills? And I'm like, they're non-existent, but I can read it and Google it and figure it out. And if we need to put something in, we can do it. That may sound like a joke, but that is real life. It's not complex. IP tables, it's a command line tool used to manage firewall rules in Linux systems. So it allows the users to configure and filter network traffic based on various criteria, such as sourced destination IPs, ports, protocols, and packet types. So IP tables, we're just thinking firewall on the Linux system. Now, this chart is overwhelming and very confusing. You can have all of your tables, your filters, your natting, raw data. You have all of your commands to put in here for your switch options and chains. Chain is just a list of rules that match the set of packets. And just giving you some examples here. And another example here. If we want to block outbound SSH traffic, we can do the IP tables command and give it the switch option of tac A. Tac A is for appending. So we're appending our master table here within our firewall rules to say the output on protocol, P stands for protocol, so TCP, and the D port, destination port of 22. 22, as we covered, is SSH, tac J, and then your action. to jump to the next target that you're doing and drop. So you can drop packets, reject packets, or accept and allow through the firewall. Those are kind of the main actions you should be aware of when you're thinking about IP tables. Let's take a look at a couple more examples. Block incoming traffic from a specific IP address. So IP tables, append the input, the source IP, 192.168.1.100, the action to drop. Allow incoming traffic to a specific port. IP tables, we're going to append the input on protocol TCP, destination port of 22, and the action we're going to accept. So we're allowing in SSH for whatever reason, or redirect traffic from one port to another. You can have this syntax example a bit more advanced. What do you need to take away from this slide? If you hear the term IP tables, we're going to think it's the command line tool to use and manage firewall rules in Linux systems. You can be aware of some of the different switch options here, and maybe these 3 action items that you can take for setting up your firewall to either accept, reject, or drop packets. Another key terminology you should be familiar with, it's going to come up throughout your career, is syslog. So syslog is basically a standard way for logging and information coming from various sources, various operating systems, to have a common schema associated to their logging. This makes it easier for administrators to collect, process, and store log messages generating from various applications and services. They include information about the source of the message, severity level, a timestamp, other relevant details. It can be used to transmit log messages between network devices over UDP or TCP/IP protocols. And probably the bullet to remember, the Linux operating system includes the syslog daemon called syslog-d, which is responsible for collecting, processing, and storing system logs. Other operating systems may use different implementations of the syslog protocol, but the basic functionality remains the same. So it's a centralized logging protocol used to collect everything from a bunch of different devices and operating system, convert it into the syslog format, and it's a basic way for administrators to go in, troubleshoot, read the logs, and figure out what's going on. Syslog function sends messages generated by the kernel and system utilities into the syslog daemon. It's like a diary for everyone to journal in and then troubleshoot if needed. So all these people are writing to the diary every day with their logs that they're generating, all going to be converted into the same standard protocol for logging their messages, and the admin can go in, read the diary, and start troubleshooting and figuring out what's going on if they need to fix something or read the logs related to a specific system. Some samples here for what syslog data can look like. We have a date timestamp, a host, information about the kernel, core temperature above threshold, CPU clock throttled, failed passwords for root from this IP on this port, cron job, getting started, an error code, file does not exist, other stuff happening for mail protocol to user at example. Anyways, it's a standardized logging format, and it makes it easier for us to ingest a bunch of different logs coming from different devices and applications, operating systems, and put it into a similar structured format. So if you hear of syslog-ng, this is an open source logging daemon that collects, parses, and stores syslog messages from various sources into that centralized location. You can have syslog-ng or rsyslog to kind of do the same thing. And this is kind of what you're going to use for logging your messages, standing up syslog, collect, process, and analyze those logs from all those different variety of sources. So syslog-ng, rsyslog, you should be familiar with those terminologies, what they are, and what syslog is, and why would we want to leverage it. Wrap it up here with some best resources for learning Linux. A great one is the Linux Academy on YouTube. a bunch of subscribers, great video content, a great project for what they're doing, all 100% free. We love free here at Blue Team Consulting, so definitely take advantage of, the YouTube University. Linux Hint, another great resource. You got to pay a little bit, but the investment is worth it if you get higher quality content. It's FOSS, another website, and Linux Journey. Just want to call out some commands here. If Linux is a free and open source tool, a lot of the people who spend their career mastering Linux believe in keeping all the training and material and resources and how-tos also free and open source to the community for everyone to leverage. So a great community to be a part of, definitely a skill to learn for your career, to go out and learn Linux. I would definitely master some of the commands that were on that one slide. Go to the Linux Academy or some of these other sites. TryHackMe has a Linux Foundations course as well. RangeForce has a great Linux course with like 22 modules in it for mastering Linux. Covers all the key concepts that you need to know. So hopefully this Linux module was a lot more digestible than the beast that is the Windows operating system, and it's more user-friendly, not as much of a headache, and more intuitive.